Hello, my name is Katherine Westerlund, and today I'll be presenting a poster titled The Influence of Geomechanical Conditions on Pad Level Decisions from Oil and Gas Wells in the Permian Basin, a preliminary report. This is work that is being conducted at the University of Toronto with the geomechanics group there. To start things off, we'll look at a bit of a background. So during the stages of hydraulic fracturing, fluid and proppants are pumped into the ground to kind of increase reservoir permeability and allow for the improved extraction of subsurface hydrocarbon resources. This is what allows kind of hydraulic fracturing to be a productive method of extracting oil and gas from the ground. There has obviously been significant study over these processes, and operators have a significant amount of control over a number of variables in this process, including things like proppant mass, pumping speeds, and the orientation of the perforation. So how the fluid and proppants are impacting your rock mass around it. To date, there has been significant exploration and documented research about how the kind of general reservoir geomechanical properties can influence this hydrocarbon extraction. However, what we note is that most of this research has been conducted for the properties that are observed during the reservoir-dominated phase. And so this research proposes to do more of an investigation into the properties that are identified during the fracture-dominated phase and how those might influence overall recovery of these systems. The why of this research is that it is important both for efficiency reasons and for sustainability reasons to be able to modulate this well control and the proppant levels for optimum recovery. Research is to investigate the relationships among the subsurface conditions, these pad level controllable variables, so variables that may be able to be modulated with the subsurface conditions, and the influence of kind of fracture-driven interactions, with the aim of managing these fracture-driven interactions in regions of very dense wells and with high potential for fault activity. The region that was identified here is the Permian Basin, specifically down in Texas. The idea here is that by advancing our understanding of the geotechnical conditions and the production variables, we can derive insights that facilitate improved production control and enhanced hydrocarbon recovery, which would be of value. Permian Basin was selected for this study due to the kind of extensive population and history of the American oil and gas industry. The history dates back to the 1960s, and the basin has provided a robust data set because of this, with significant kind of modeling insights from the past and also many wells currently in production. Therefore, kind of trends that are identified can be then applied to those locations. Also critically, this is a location of significant kind of fault activity and potential for seismicity, potential for fault slip events. What is proposed in this research is to develop, to use kind of new data processing and pattern recognition techniques, including those documented in machine learning algorithms, to derive a deeper understanding of the influence and the potential causality associated with these measurable subsurface conditions on oil well production, with the goal of them being able to tailor oil well production to those subsurface conditions. These potential sources of data are located primarily from Enverus as well as Shearfrac, and these include things like well locations, downhole geophysics, drilling conditions, regional geology as well as fault mapping, production data, and regional seismicity. We propose a 3-stage process in which the data is collected and cleaned. A machine learning model is built using Python and scikit-learn, and then finally that process is verified using the real-world data from a pad currently in production. Thank you for your interest.